Just so I ruined it for you, Denny dies in the next chapter. He gets hit by a truck. Oh, that's right. I forgot.
Lenny dies in a
Kill a mockingbird. He gets hit by a truck while he was trying to kill a mockingbird.
Yeah, he does.
Lenny dies
So we do the same thing. We do the same thing as we've been working on. Started out by finding your x-intercepts, just like we did earlier today. X-intercept, got a fact at the top, x minus 3, x plus 1. So you have them at 3 and negative 1. What times what's negative 3 and together get negative 2?
It's going to take me a little bit to think.
Okay. So your vertical asymptote's going to be at... How'd you get that so fast? So there. And then last but not least, do we have a horizontal asymptote? No. No horizontal asymptote. So we start to plot in picking points. Asymptotes plus negative 4. X-intercepts at negative 1 and 3.
You know what really helped me was when to tell horizontal from vertical was when you told me about a roller coaster and you can't go horizontal.
Of what?
Down a roller coaster or something like that. That's the only thing that's helped me.
And now it's a matter of trying to figure out what in the world is going on.
You can't drop.
So we have a couple of points already on the right side of the asymptote. But let's pick another point that's pretty easy to work with. 0. If I use 0, I'm going to get my y-intercept, correct? So if I use 0, I'm going to get negative 3/4.
Yeah.
Oh, yeah.
Because all I'm doing is covering up all that and I get negative 3/4. Still not exactly sure what this curve's going to do on that side. So let's use 1. Or better yet, let's use negative 3. Let's see what's happening a little bit closer to that. Let's use negative 3. Just subtract 4.
True. Not there. I'm okay with that.
Negative 3. What's negative 3 squared? 9. So we have 9. Negative 3 times negative 2?
6.
What's 9 plus 3? 12. What's 12 divided by negative 1? Oh, sorry, 12 divided by 1 here. Excuse me. So it looks like it's probably doing this. And I'm going to explain to you guys the reason why I know that right-hand side is probably doing that. Bless you. Yeah, Cole.
On the quiz tomorrow, are we gonna have to?
There's a quiz tomorrow.
Is there a quiz tomorrow?
I thought there was.
I don't know.
Today Wednesday.
I don't know. Today's Wednesday. We'll probably do it Friday.
Okay. You
Do
said
it
Thursday
Friday.
earlier.
We're going Friday. We're going Friday. Friday's good.
Let's just do it
On
Friday.
the quiz
Yeah.
on
Yeah,
Friday.
Friday.
Monday.
Friday, on Friday.
Are we gonna have to label the points?
Yeah.
Okay.
What I want you guys to do when we're doing these things is I want a couple of points on either side of the asymptote, and then usually you want to throw in the y-intercept, things like that. One of the reasons, and the reason that I know that this tail is doing that, look at the degrees of the numerator versus the denominator. What do you notice? There's 1 degree more on the numerator. I go from a squared term to a linear term on the bottom. When that occurs, This is the situation that will occur when you have what's called a slant asymptote. If you have an x squared up top and an x on the bottom, you can find the equation of the slant asymptote by long division. It'll put it in the slope-intercept form right off the bat. So what I want to do is, on a separate slide here real quick, is just walk you through x squared minus 2x minus 3 divided by x plus 4, long division. And we'll go back to our graph. When you're doing long division with polynomials, remember what you're trying to do is eliminate terms as you're going along. And it was pretty straightforward where it was, how do I turn the x into an x squared? What do you multiply it by?
X.
X, very good. So what I had to do was put the x above here, distribute the x to both parts on the outside, and then what? Subtract both times. Good. Very good. So then I have negative 2 minus 4.
Negative 6.
Yep. I have negative 6x. Bring down the negative 3. How do I turn the negative 6x, let me rephrase that. How do I turn the x into the negative 6x?
Negative 6.
Excellent. So we have negative 6x minus 24. And then I would subtract again. And I get 0, and then I have a 21. Now, that 21 is the remainder.
21 over x plus 4.
Correct. But since what I'm looking for here is what's called the slant asymptote, the slant asymptote is always going to be in mx plus b format. It's just x minus 6. That's the equation of the line that has of the slant asymptote for our graph. Yeah, you don't need the remainder. In other words, you don't need the remainder. So it's not pulling teeth, is it?
So it's 6.
What's that?
So it's 6.
It's not 6, it's x minus 6 would be the slant asymptote. So if I go back over here,
You said it was 0.
I'm trying to make this look right. There's a slant asymptote
Huh? Okay, how?
doing that.
The slant is 1. Okay.
The slant has a slope of 1 with a y-intercept of negative 6.
Oh.
Okay. Let me show you this in your calculator, and you might be able to visualize it better if you see it there. I think this is the problem here. No, it was close to it. What's the equation again, guys?
X squared minus 2x.
Alpha y equals x squared x plus 4? Thank you. You might have to move around a little bit with your windows to see it a little bit better. I had mine set from a problem we did yesterday, so let me change my window to negative 10 by, let's do, actually I want to do negative 30 by 30. Then do negative 30 by 30 on the other one. I think that it should work out. Yeah, you should see it now. You see how what happens what happens here is that you were going to get this slant asymptote that occurs. The slant asymptote will occur when you have second degree over first degree. Yes, sir.
Does that only mean second degree is first degree of weighting?
It will work with the third degree over second degree and all that kind of stuff, but I think the Algebra 2 book only goes second degree over first degree. This is not even in your book. This is a pre-calc thing, but it's honors. Might as well show you. It's one step.
Is it gonna be on the quiz on Friday?
To find a slant asymptote, if needed, yeah, it's just quick long division. I mean, if you guys, if you bear with me on this one, the long division in here was really, it was just 2 steps. As long as you remember to subtract that second term, which here is what the mistake that most of you guys make when you do your long division. If you remember to do that, you're going to be okay. All right, you're going to be all right. That's really the only trick there is. So now we have this. We have that slant asymptote. Got lines everywhere.
Does it have to be a dotted line?
Whoa. Uh-oh.
Group it. Oh, it's like a, what is that called?
I don't know.
Crankshaft.
Yeah.
Sure. Yeah, not really.
Crankshaft, yeah, crankshaft in an engine here. Makes the,
She doesn't know her.
Yep.
Like a car. It's car talk.
what?
I don't know what to do either.
So now we have that one side. The other side, we still got to get a couple of points. So, yeah, we'll use like -5,
-5 is 2.
and then negative, I don't know,
It's not on my graph.
6.
I can't do it.
Okay. If I use -5, I'm going to get 25 plus, what is that? Plus 10 minus 3 over -1. So that would be 35 negative 32. Would be 32 be negative 32. So 5 and negative 32.
Just put it somewhere.
Somewhere down here.
This
I don't like the plot, but then we did that day.
Yeah.
Go for that.
I will do my best to get stuff that fit nicer in the windows and stuff. And then -6, obviously you plot that through. But one of the things you should be able to notice then is that it will come up, hug it, and go back around. All right. Remember, when you're graphing these things, you're hugging asymptotes, going through your points and hugging asymptotes. Yes, sir.
How do you know what points you read?
Pretty much. I'm usually picking a couple that are close to the asymptotes, just trying to get an idea of where things are going. You can pick any number you want. It's just, it's usually the couple right after asymptotes. All right. Let's do another one.
So the -5 and the -6 is a different thingy.
Yeah. I just didn't do it because I want to do more examples.
You know what you said when you said that you should try to do your fire?
Yeah.
What is it?
It's, then you don't need it. All I'm saying is sometimes it's a nice easy point to find, that's all. But you should always have a y-intercept, don't you think? If it's an x squared term? Right, it should be 0. Unless the asymptote's going to have a hole in it. That's something you'll do next year. What were you saying?
0.
We're doing the actual graphs today. We're going to do more of the... Yeah, the ones we did, but I'm trying to get more of the ones that'll work a little bit cleaner for you. All right, let's try another one. Let's do x over x squared plus 1.
Okay.
We do x over x squared plus 1. We start with the exact same thing like we were doing earlier. Find your x-intercept. Find your vertical asymptotes. Go through the degrees, see where things go, and then it's just a matter of plotting points. This one's fairly straightforward. Where's your x-intercept?
0
Vertical asymptotes?
plus or minus square root 1. Why is it none this time? No magic.
X squared plus 1?
Oh, it's negative.
Yeah. Horizontal asymptotes? Wait. Top is larger than the bottom. Or sorry. I forgot that 1 is less than 2.
So your method.
I forgot that one.
Wow, this is great, you know?
Yes,
done.
ma'am.
Are we going to be able to use this sheet
I don't know, I haven't decided, probably not.
Probably not.
And now it's just a matter of plotting through.
Why isn't
Pick values.
One.
-2, -1, 0, 1, and 2. So if it's -2, we get -2 over 5.
So,
At -1, we get -1 over 2. Yeah. 0 is 0. At 1, it was 1/2. And then at 2, it's 2/5. So -2, -2/5. Is -2/5 smaller than or greater than, what do you call it?
it's smaller than? What do you call them?
this.
So let's take a look and see how close we are.
Wait. How is it?
Those are those things again.
Why is it underneath?
Oh, we gotta change my window here.
It's cute.
Isn't it supposed to be positive?
It's positive. Yeah.
Did I plot on the wrong one? Yeah, sorry about that. I just realized that.
I was wondering, and I was like, huh?
Yeah, I just realized I did that.
I guess it's okay.
Yes.
You have to do sound effects when you're doing this. It's more fun.
Mike.
I hate mail.
That's my sound effect.
All right. Yeah. Should we try this with the graph paper? Let's try with graph paper once.
No.
Might as well.
No.
Let's try to do it with graph paper. Why not? I have graph paper. Let's see what we can do. I have graph paper. I'd be more than happy to share with you graph paper. Oh, that's right. You have graph paper. Let's try to do this on graph paper. Hey, what can you tell that this graph's going to have right away? Why is the asymptote there? Because it jumps through. It actually works because even though the degree is because the bottom is it's one of those rare exceptions. It's still there because the other values are approaching it later on the tail end. It's not a peak. It really isn't. You'll talk more about that later. It's just there's no for us right now. It's not a really big deal. It has to deal with poles and factors and stuff. Mainly it's because the denominator, but also when you get into pre-calculation, you can have factors that balance themselves out. So you could have like a zero denominator, but it can't stop the front of the numerator, and then that might mean a hole in the graph. So there's a lot of these little weird things that can happen. So this is more general. So let's walk through this and try and see what we can do as far as plotting and actually using graph paper for a change, and see how we can plot and put in a slant asymptote as well. So we start with our x-intercepts. we have x minus 4, x plus 1. So my x-intercepts are at 4 and negative 1. Vertical asymptote at x equals 2. I don't have any horizontal asymptote because the degree in the top is larger than the bottom. So what I'm going to do here is go right for and get my slant asymptote. My slant asymptote, do a little long division here.
There's not enough room on this paper.
Top is bigger.
My slant asymptote goes off at x minus 1. Sorry. I get going too fast sometimes. So when I go and do these things, I'm going to put in my asymptotes and my intercepts just like I did earlier. Negative 1, positive 4, vertical asymptote at 2. Try to make it straight. And then I'm going to go ahead and plot in my slant asymptote. Start your slope.
Negative 1.
Appreciate the sound.
The sound effect. Sound effect. Yeah.
Oh, that's much better. How do you get that? With the slant? Long division. Yeah, it's y equals mx plus b. The slant asymptote is always written as a linear function.
And then to intercept.
Start at negative 1 and 1. So this is y equals x minus 1. So you just graph y equals x minus 1.
This was easy. Wait,
Because and that's the whole idea. Even if you had a third degree on top and a second degree on the bottom, when you divide it out, you're going to wind up with a linear function. It still works the same, but I don't think we see very many of those in this book.
this is all we can do.
Now you could probably tell what points I'm going to start to pick. What's one that I'm going to pick real fast because it's easy?
0.
0, correct. Because what is negative 4 divided by negative 2? 2.
Duh.
So I know that at 0, it's 2.
1, 2.
I declare a thumb war.
Oh.
I
see that coming.
Fish hooks, yeah.
Wait, what'd you say?
No.
What's fish tail?
Is it fish hooks, eat 'em up?
No, not that. No, not that.
Oh my god.
Is fish hooks on
It's on Disney. It was on Disney.
Anyway, so I've got that one. We should probably... Guys. Hey guys.
1, 2.
We should probably... We need to pick another value on the right-hand side. 5? Okay. So if I use 5, I'm going to get 25 minus 15 minus 4 over 3. I get 5 squared is 25, 3 times 5 is 15, so you get 25 minus 15 is 10, minus 4 is 6, 6 divided by 3 is 2. Since we probably know by now that we like to hug our asymptotes,
Wait.
It's
So
1,
in this case, we only have to do 1 on each side.
it worked out that way because we had the intercepts. And it's and the other reason is because we had that slant. Because we know that we hug asymptotes and do this. And that's exactly what it should look like. It's really nice. It's really nice. Yeah. Let's do another one. Oh, I wouldn't want one.
Can we not do it on the graph paper?
I don't like it on the ground.
I don't like it.
No, I guess it's in you can't. We try to fake it. It's not true because I'm not always tricky with it. What size is it? What? I've never heard of one. You're dead.
All right.
I literally woke up.
Let's try this one. Y equals x squared plus 2 over x squared minus 16. X-intercepts, do we have any?
No,
No, very good. Why don't we have x-intercepts?
because it's not an imaginary number.
Good, good, good. No x-intercepts. Vertical asymptotes.
Is it 4?
16. Plus minus 4.
Plus minus 4.
Cody was so excited when he got that.
I know. 16! Oh!
I got it right.
Hey, it's 90% how you sell it. That's all I got. And then horizontal asymptote.
1.
One.
Good. Why is it 1?
Because
Because
you
it's equal, so it's
1 and 1
1.
equal 1. I don't know
Do
how
we
else
have
to
to
say
find
it.
a slant asymptote?
Nothing.
Is there a slant asymptote?
Do we have to find
There
it?
is not.
There is not. Why is there not a
Because
slant
the top
asymptote?
one is not bigger than the bottom one.
The coefficients are the same.
The only time I'm going to want you to find a slant asymptote is if your degree on the top is 1, yeah, is 1 more than the degree on the bottom. We're just making a slant asymptote. Yes, it's a slant asymptote. Thank you.
Swiggle.
I said squiggle.
Squiggle, that's what it is.
Squiggle.
Squiggly.
All right, look at that.
No thanks.
So where's the easiest point to pick?
0.
0. What's your y-intercept?
0.
Oh, it's
-8.
This is too much.
Now, what happens when you have one where you've got, you notice how we broke it into kind of like 6 different quadrants now?
Yeah.
You're going to have to pick a couple points within each set of the domains. Now, even though I have that value of 0, I would still want to pick 2 other points. Everybody know what way the curve's going. It's probably moving downward because it's not going to go up to its asymptote. And then you pick 2 more on either side of the vertical asymptotes. Let's try and do some of these on graph paper tricks. They should work out. What do you have? 1, 2, 3, 4. You have 10 spots left. So let's see here. Let's do.
10 is too many. I like 8.
So this is still 9-3. This is on page 551. 26.
Oh, shoot. I've not done anything.
Oh, jeez. 26 to 31, and I'm trying to do one more. And 36. Try those.
Alright.
That's only 7. Nice.
All right.
Thanks.
Try those. Remember, if your degree is 1 more in the numerator than it is in the bottom, graph a slant, okay?
What was it doing on the graph?
Sorry, what's that? It'll still work because as soon as you put, as soon as you go, yeah, try to put my graphics. I think these should work cleaner than what they were doing before. Okay?
give perspective of the book. And you want to know the our class?
What's that?
Yeah. It might be a little ratchet, because like, if you ask for it, it's